today we are starting with one of the most powerful inventions behind the modern AI, architecture of transformer. Transformer does only one thing. It predicts the next word, right? That's it. It doesn't think like human, it doesn't plan ahead, it doesn't understand emotions. It simply predicts the next word. Okay, it simply answers the question, okay, based on everything I have seen so far, what word should come next. It just asks this question again and again. So since it is repeating this question thousands of times, it creates a long intelligent looking answers. I told you in my previous video that write a story. If we ask a write a story to ChatGPT, it doesn't write a story immediately, right? So it asks what is the next word. Okay, maybe it choose once. Now the input becomes write a story once. Okay, next word is upon. Then a time. Okay, by guessing one word at a time, a full story slowly appears. This is exactly how ChatGPT works. Okay, now let's come to a transformer. What is transformer? You can think transformer is like a factory. Okay, so text goes in, and inside that factory many smart steps happening, and one word which comes out of the factory. Okay, so inside this factory it has 6 important stages. Okay, we'll see one by one. First, the transformer is made of encoders and decoders. Okay, so encoder, what is the actual work of encoder? It reads and understands the input sentence. What is the actual task of decoder? It uses that understanding to generate an output. Okay, so the example I could say is a translation. Okay, if you're giving some French text, it gets translated to English. Okay, for this it requires both encoders and decoders, because encoder read the French text and understands the input sentence, and the decoder, based on that understanding, it generates the translated English sentence as an output. So if you are only generating text like a ChatGPT, you might only use the decoder part. Okay, so let's see what are the parts that are inside. The first one is tokenization. What is tokenization? It is breaking the text into pieces. Okay, because computer don't understand sentences, so the sentence is broken into small pieces called tokens. Okay, that's why it's called tokenization. For example, write a story dot. Okay, now write is become one token, become one token, story become one token, even the punctuation become one token, even the punctuation matters. Okay, so that is all about the tokenization, breaking the text into pieces. So the next important stage is embeddings. Embeddings means turning words into numbers. Computer understand numbers, not words, as we all know. So each word is converted into numbers that represents its meaning. How it is representing its meaning? See, the words with similar meaning, they'll get a similar numbers. For example, apple, banana, orange, all are fruits, so they all live close together. Okay, if there is a word like castle, it is very far away from that. Imagine the words in a multi-dimensional space. Okay, for this video I can show you only in the 2 planes, so I'm showing this, but imagine the words are converted, the words are placed in a multi-dimensional space. Okay, so the numbers, the similar ones will be close together, and the castle that is far away, it's because it's based on the meaning. Okay, imagine it's a map of meanings where similar words live near each other, so that map is called an embeddings. Is that clear? Next is positional encoding. What is positional encoding? So you have to remember the order, right? So machine don't know the word order naturally. Okay, so we add extra signals to show where each word sits in a sentence, whether it's a beginning or in the middle or in the end. Okay, so why we have the positional encoding? For example, a dog bites man, man bites dog. These are all same words, but the sentence is giving very different meaning. So this is the reason we add a position information. This is the first word, second word, third word. Okay, you can think like we're assigning a seat number. Okay, so the model knows who comes first. That is all about positional encoding. Okay, then comes the attention. Attention is the heart of the transformers. Okay, this is the most important part. What is attention? We discussed already, no? In the attention decides which words should pay attention to which words. Right? For example, please buy an apple and an orange. Here the apple refers to fruit. Consider the sentence 2. Apple released a new phone. Here the apple is a company. Apple is the same word but it is giving different meaning. Why? Because the surrounding words pull meaning. Right? You can imagine the attention is like a gravitational pull between the words. Okay, and I can give you another famous example, the it example. The sentence is, the bear ate the honey because it was. What is it here? Is it a beer or is it a honey? If the next word in the sentence is hungry, then it's going to be a beer. If the next word is delicious, then it's going to be a honey. So attention allows the model to connect the correct words even across the long sentence. So that's the real power of transformers. Okay, then we have something called feed forward network. So it's a brain engine, So after attention adds a context, the data goes into a big neural network. Okay, so its job is score every possible next word. So it doesn't choose it, it just says this word is very likely, that word is less likely, kind of. Okay, then comes the softmax, that is the final one. It helps you to choose the word. Now we don't want the same reply every time. So the scores are returned into probabilities. The scores are turned into probabilities. The high score, high chance. Low score, low chance. So one word is selected based on probability. So that's why the answer always feels natural. The responses changes slightly every time in ChatGPT. So repeat this loop. So one word is chosen, it's added back to the input. Then the model predicts the next word again. So this repeats until the sentence ends. So now you understand why the transformer is so powerful. Because inside the model, it has attention and neural network, right? And attention, neural network. This gets repeated many times. Okay, so each layer understands the sentence much better. So more layers, a deeper understanding. So that is all about today. So I can tell you a final big takeaway here is a transformer is a huge neural network that predicts the next word using context and attention. Okay, one word at a time. That's it. So in my next video, we are going to see what is prompt engineering. Let's learn GenAI together. Thank you for being here.